Hi, I'm Colin G. West. Last Thursday, when I should have been working, I got a little distracted trying to understand how cosmologists talk about the distance to faraway black holes. If you could use a little scientific distraction too, come join me. You can think about this. Okay, so backstory. Last week, a big group of scientists working in a collaboration called LIGO announced that they detected something called a gravitational wave arriving at planet Earth. Now, LIGO and gravitational waves are both super cool and super complicated, but they're not really the point of this video. So if you want to learn more about them, check out the links in the video description below. These gravitational waves came from two massive black holes that collided and formed one even bigger black hole. And last week, I was trying to write a tweet about this, saying that the black hole was formed a long time ago in a galaxy far, far away. Obviously, I think I'm incredibly clever. But the point is, when I tried to get specific about how long ago and how far away, things started to get more complicated than I expected. Gravitational waves travel at the speed of light, so at first I thought it would be easy to figure out how long ago they were created. For example, if the black hole had been 3 light years away from us, that would mean that things moving at the speed of light take 3 years to reach us. And that's what a light year is. It's how far you can go by traveling at the speed of light for a full year. Well, these black holes were 3 billion light years away, so originally I thought the gravitational waves had taken 3 billion years to reach us. But when I tried to do the calculation to check, the numbers just didn't add up, no pun intended. I kept getting a smaller number and I didn't understand why. Now, I'm not an expert in this kind of physics, so I had to crack open my old cosmology textbooks and call up some of my friends and colleagues. Don't ever let anyone tell you that scientists don't have exciting social lives. So here's the key. These black holes are so far away, they're in a completely different galaxy. And the universe is expanding in all directions, meaning the distant galaxies are all moving away from one another all the time. So that makes understanding the distance between these black holes and Earth a little bit complicated. In this context, there's actually at least 3 different things you might mean when you use the word distance. First of all, you might mean the distance between the black holes and the Earth when the black holes collided and the gravitational waves were first emitted, which turns out was about 2 billion light years, because back then, the universe was a smaller place. Alternatively, you might mean the distance that the waves traveled in order to reach us, which is actually about 2.3 billion light years, because the Earth has been moving away from the waves the whole time they were traveling towards us. Or third, you might mean the distance from the Earth to the black holes at the moment the waves arrived. And that distance is about 3 billion light years. Because while the waves were traveling and the Earth was moving away from the waves, the black hole was also moving away in the opposite direction. Whenever you want to talk about the distance to an object so far away that the expansion of the universe is pushing it away from you, and vice versa, then it becomes difficult to even agree what the word distance should mean. You have to specify in context. On top of all that, there are different ways to determine the distance, like by looking at the size of the object or the brightness of the object, and these methods are all affected differently by the expansion of the universe. And to calculate any of this stuff, we not only have to know that the universe is expanding, we have to have a pretty good estimate of how fast it's expanding. Actually, because of these complications, cosmologists and astrophysicists often try to avoid talking directly about the distance to an object altogether. Instead, they use something called the object's redshift, which indirectly captures the same information. But we're out of time, so if you want to learn more about that, or just need more sciencey distraction, you should start by looking that up on your own. So, there you have it. I hope you learned something from today's little science distraction. And if you liked the episode, click the like button, subscribe to the channel, and share it with your friends. If you have follow-up questions, or you want to suggest topics for future episodes, you can tweet them at me at ColinGWest, because I am Colin G. West. Thanks for watching. We'll see you next time.